If you have a giant piece of data that's in an array and you only need to see part of it, perhaps np.compress can help. Here's a random matrix A. np.compress takes in a 1D array of booleans, an array to compress, and the access to compress on. So if we type np.compress, we'll give it an array with just a single truth value, our matrix A, and we'll go ahead and specify access equals 0. And this returns the first row. Access equals 0 corresponds to rows, and since we put true, it just gives back the first row. Next, we'll do the same thing, give it A, but this time we'll do access equals 1. Access equals 1 corresponds to the columns. So there we have our first column since we gave it only one truth value. Alright, here's our matrix A once again, np.compress. You can also give it masks. So we'll go ahead and give it a mask here, A greater than 0. But be careful not to give it a mask that's more than one dimension, so we'll just take the first row of that mask. There's no number in the first row that is greater than 0. You have a 0, -6, and -5, and so it doesn't return anything since those are all false. Okay, let's do np.compress. We'll give it the mask of A greater than 0 once again, and this time let's give it a different row to base it off of. Let's give it the second index or last row, A in access equals 1. So it's going to take any column where the last row is greater than 0. So we have 1 right here that's greater than 0, so it gets that column, and 2 is greater than 0, so it also gets that column. Alright, here's A once again. Let's do np.compress. We'll give it a mask, A greater than 0. And let's give it a single column to base it off of, so colon, comma, 1. So for the middle column, we're going to do access equals 0. So it'll give us any row where the middle column is greater than 0. So 4 and 1 are greater than 0, so it will give us those two rows. Here's A once again, np.compress, A greater than 0, and this time we'll do colon, comma, 2 for the last column. But this time we will not specify an access. When you don't specify an access, it defaults to none and works on the flattened array. So now we have A greater than 0 in the last column. So since -5 was not true, we don't see the 0, but since 9 and 2 are both greater than 0, in the first row it will give us the last 2, so that's why we see the -6 and -5. Let's do that again, but base it off of the middle column. Alright, so the middle column is actually a very similar story. We have a -6, which is false, and then we have a 4 and a 1, which are both true. When you don't specify an access, it defaults to none and works on the flattened array. We'll take -6 and -5 once again because 4 and 1 are both positive. So there you have it. That is a few examples of how you can use NumPy's compress function. Be sure to check out some of my other Python videos, and don't forget to hit subscribe.